Okay, we've done some work on finding the angle of the centre of the sector when we've been given the area of the sector or given the length of the arc. So these kind of working backwards questions when we've got the result of the length of arc of the area of sector. Ones that we haven't looked at yet is when you've got the angle at the centre and the length of arc area of the sector, but you don't have the radius, and that's what we're going to look at just now. So we're going to call this title Finding the Radius. Of a sector given other information, and the other information at hand is the angle at the centre, the area of the sector, or the length of the arc. So let's try an example 1. So example 1, we've got a sector showing the angle at the centre is 30 degrees. The radius is the thing that I'm looking for, but I'm told that the area of the sector is equal to 6.5 square centimetres. And the task is to find the radius. Okay, so we can go back to that handy ratio, which is a over pi r squared is equal to theta over 360. Now what we can do at that point is just perform a wee trick. We're looking for the radius here. What we can do is we can flip this ratio upside down and say that pi r squared over a is equal to 360 over theta, and what we've did there is just flip the fractions upside down. And that's okay, we can do that. If we think, for example, that 1/2 is equal to 4x, well, if they flip them upside down, then 2 over 1 is 2 and 8 over 4 is 2. So it's fine that I can do that. Okay, now I'm looking to isolate r on its own. So I'm first of all going to get rid of that divide a by multiplying by a. So I'm looking for the radius, remember, so pi r squared then is equal to 360 divided by theta, and I'm going to bring that divide a up and multiply, so that's going to be multiplied by a. I can then get the multiplied pi and bring that down, so that will be r squared equals 360. Okay, so the multiplied by pi is coming down, divide by theta pi times a. I can then take the square root, get rid of the squared by taking the square root, and that's going to be 360 divided by pi theta times a. Okay, now after I've done that work, I'm now in the position to put some numbers in. Okay, so I should have given some information to go in with the question. So we're going to say that for this question, the area of the sector is 6.5 square centimetres. Okay, and we do know that the angle inside is 30 degrees. So let's throw that in. That will be r equals the square root of 360 over 30 times pi multiplied by the area, which is 6.5, and then I can enter all that into the calculator. And to one decimal place, that will give me 5.0 centimetres. Okay, so let's just review that question and go over the steps. Okay, so the first thing was I picked out the ratio pi r squared over a equals 360 over theta, and that's one just for remembering now. So we picked that one out a couple of times. So pi r squared over a equals 360 over theta. What I did then was I flipped that ratio on its head, and basically what that meant was just flipping it upside down. A over pi r squared equals theta over 360, which we can do. So I showed you an example of that working there, so let's try it again. So if we had 5 out of 10 well, that's the same as scoring half marks. We'll flip it upside down. 10 over 5 is 2 and 2 over 1 is 2. That works. Okay, so at that point, I flipped upside down. And I'm looking to change the subject formula to end up with only the radius. So the first thing is to get rid of the divide by a, by times and by a. Then get rid of the times by dividing by pi, and then to take the square root to get rid of the square. Enter all into the calculator into one decimal place, 5.0 centimetres, but let's try a second example. Okay, example 2. This time I've got a sector with a smaller angle at the middle. Let's say it's 15 degrees. I don't know the radius. That's what I'm after. That's what I'm looking for. And I'm told that the area of the sector is 8 square centimetres. And the thing is to find the radius. So again, I'm going to recall that handy formula, which is a over pi r squared is equal to theta over 360. I'm going to then flip that upside down. Pi r squared over a is equal to 360 over theta. I'm then going to change the subject of the formula to what I'm looking for, which is the radius. So the first thing that I need to do then is to get rid of that divide by a by multiplying by a. So that's going to be pi r squared is equal to 360 over theta multiplied by a. I'm now going to look to get rid of the next thing, which is times pi by bringing that down dividing. So that's going to be r squared equals 360, and then bring it down. That's going to be divided by theta with the pi down there as well, times a. And now eliminate the square by taking the square root. So that will then give me r equals the square root of 360 over theta times pi times a, and I can enter all that into the calculator now. So I know that the angle is 15 degrees and the area of the sector is 8. Okay, so the angle at the centre is 15 degrees and the area is 8. So that's 360 over 15 pi times 8. Pick up the calculator and enter it in. And to one decimal place this time, that's 7.8 centimetres. Okay, we've looked at two examples where we're looking for the radius given the area of the sector, but we've also experienced questions when we're given the length of the arc. So let's look at one of those type. Okay, bigger angle at the centre this time, we'll say it's 60 degrees. We're still looking for the radius, that's unknown. Now this time, instead of giving you information about the area of the sector, let's say it's the length of the arc information. Let's say the length of the arc for this one is 8.5 centimetres. Okay, now remember that bigger ratio that we looked at, which was a over pi r squared equals theta over 360, and that's also equal to the length of the arc over pi d. What bit we're interested in this time? Well, it's the length of the arc bit. So rather than select this bit of the ratio, let's select this bit. That's what I'm interested in. So let's go for that then. That's going to be theta over 360 is equal to the length of the arc over pi d. Now what I'm after with this question is the radius. Now if you think about it, if I get the diameter, I'm very close to getting the radius. So let's do that thing where I'm going to flip this ratio on its head so that I can get the d up there, which is quite convenient to start with, and it's a really easy move. So flipping its head, 360 over theta is equal to pi d over length of arc. Okay, again, I'm looking for the radius, so if I get the diameter, I'm very close. So next move is let's bring the length of arc up and multiply. So now I've got pi times the diameter is equal to this 360 over theta, and then I'm bringing the length of arc up and multiplying. Okay, I can then get the diameter by bringing the pi down and dividing. So that will be d equals 360 over theta with pi beside it down there, multiplied by the length of the arc. Okay, so remember that the information given was that the angle at the centre was 60 and that the length of the arc was 8.4, so I can feed that in. So that's 360 divided by 60 pi times the length of the arc, 8.4, and enter that into the calculator. Okay, into one decimal place, that'll give me 16.0 centimetres. Now, before I rest on that, it's important to think about what I'm looking for, which is the radius, not the diameter. So if the diameter is 16, to get the radius, that's easy. Just divide that by 2, since the radius is half the diameter. 16.0 divided by 2, 8.0 centimetres. Final answer. Okay, let's try one final example then. So let's use this diagram, which has got a much bigger angle at the centre, which we're going to say that that angle there is, the internal angle is 220 degrees. Again, it's about finding the radius. I'm told this time that the length of the arc is 12.1 centimetres. So I'm going to go back to the appropriate ratio, which is that the length of the arc is equal to the length of the arc over pi d is equal to theta over 360. I'm then going to do the same thing again, which is to flip these on their head so that I can get d up here, which is handy for me. So that's pi d over the length of the arc equals 360 divided by theta. Okay, so I'm looking for initially to find the diameter, and then after that the simple move to find the radius. So first thing, let's get rid of that, divide by length of arc and bring it up and multiply. So it's going to be pi d equals 360 divided by theta multiplied by the length of the arc, and then d equals, we'll bring that pi down and divide 360 over theta pi times the length of the arc. Okay, let's get the necessary information and put it in before we enter into the calculator. So what is that information again? Well, that's the length of the arc is 12.1 and that the internal angle at the centre is 220. So it's going to be 360 over 220 pi multiplied by the length of the arc, which is 12.1. I can now feed that into the calculator to see what my result is for the diameter. Okay, to one decimal place, that will give me 6.3 centimetres. I can then get the radius by dividing the diameter by 2, and that will give me 3.2 centimetres to one decimal place.